Retrofits, and she manages a lot of our research projects with the Energy Commission as well. So with that, Emily, thank you so much.
Thank you. So how does the screen look? Does it look okay?
Perfect. Your voice is perfect. All's good.
So this is the cover of our single family retrofit guide. And let's see, there we go. And I just wanted, before we get into it, thank you to all the contributing authors so far. We have a big team at Redwood Energy that contribute to these documents in little ways and big ways. We've been collaborating with Menlo Spark on these documents as well. And thank you to those who helped out with the cost data and case studies as well. So like Sean said, it's in a draft version and we're looking to release the draft pretty much as soon as possible, but we're still incorporating edits. So if you would like to be a reviewer, you can contact Sean or I for a copy. And, you know, within the document, this is going to be just like highlights and kind of inspiration to go read the document and learn more. So you guys have all heard the benefits of all electric design. So, you know, we kind of have a brief section on this in this newest version of the document, where the other versions have a longer version of the same information. But the big ones: health, safety, wealth, comfort, and climate. So part of this retrofit book, we are including electrification costs. And this is kind of just a consolidation of the whole home retrofits. And really you can approach retrofits in a variety of ways, like all at once or one appliance at a time. You can go with a full shell upgrade if you need it, etc. So there really is a range of costs depending on how you want to approach it. So kind of at the lower end, you can have all plug-in solutions. So around $3,000, and that would be like countertop induction, electric resistance equipment, window heat pumps, some plug-in DIY work. I know Sean has electrified his house in a similar way, doing countertop induction and things like that. And then at the higher end, but still within the middle range, about $20,000 if you're not going to do shell improvements. So that would be like built-in induction, heat pump water heaters, and larger heat pumps for heating and cooling. And this figure here is showing Energy Smart Ohio's case studies and some of their cost data. And I just highlighted that line there saying that there were a few projects without shell upgrades that were under that mark of 20,000. And you know, quite a few did have the shell upgrades in the scenario because they are located in Ohio, and you really want to make sure your envelope is high efficiency as well, so you're not oversizing HVAC and things like that. And yeah, there's more discussion on costs as well. We go into more detail specifically on water heating and space heating and laundry. So you can check out the document for more information on that. So because this is focused on retrofits, we really tried to focus a lot of the document on the watt diet concept. And Tom Cabot and one of our other coworkers at Redwood Energy, Dylan, I think presented on this at our last conference. And I know Tom has been a big advocate of this approach. So the concept here is that you can fit everything you need in an all-electric home on a reasonable size panel, on the average size panel of 100 watts. And we kind of outline some strategies to do that and some examples that go along with that. So just to go through them, use efficient heat pumps. Electric resistance uses 3 to 5 times as much power as heat pumps. And then higher efficiency heat pumps as well. Use higher efficiency heat pumps. So for example, mini splits are more efficient than a ducted system. You know, you're not the system itself is more efficient and you're not getting duct losses as well. And that's that figure to the right here, just kind of showing the range of different efficiencies of HVAC equipment. So the three here are ducted systems, and then these two here are, or the highest efficiency is ductless. But ductless also, you know, is within this mid-range as well. And one strategy we've been promoting is using a condensing combined washer dryer. This would be good for like a renter, or, you know, yeah, for a renter, or just if you're looking for an easy way to reduce your overall watt diet. They are plug-in ready, they're 120 volts. And then also heat pump dryers as well. There are some models that are 120 volt, but they're mostly 240. And they do use a lot less energy than a typical electric resistance dryer. And then also, one of the strategies in our examples is using a combined range and oven. You know, the NEC requires twice as much power if you do have a separate oven and range, which, you know, conceptually makes sense than if you have one system, a range, and an oven combined in one. The power allocation to that device is less overall. So again, talking about the envelope as well, it is important to insulate and air seal the home, especially in colder climates. So you end up using a smaller heat pump to heat and cool your house. And just as a note, most homes do not need more than 3 tons. And if they are reasonably insulated and regardless of the climate. I know, for example, the data I showed earlier of the case studies in Ohio, they tried to get the heat pump size to around 3 tons. So, you know, they'll improve the shell to kind of meet that 3-ton size, which is an interesting strategy because most ductwork is designed for 3-ton systems. And this figure to the right here is showing different design temperatures and heating needed from the heat pump. So the blue is with a tighter building shell, and the orange bar is with a more leaky building shell. And those are air changes in a non-pressurized house. So basically, reiterating that point that, you know, a tighter building will need less heating, so you can have a smaller heat pump. And that results in less amps and less power used. And then also, this is kind of a side note. Whoop. You can adjust the max allowed watts on your panel if you look at your hourly power usage. So there's a way to kind of like appeal your panel size by looking at your actual data. And you can learn more about that in the NEC National Electrical Code manuals and instructions and stuff like that. So another big one, also kind of the essence of retrofits and our examples in this guide are to use power sharing devices. So there's quite a few brands here. You can see the full product guide in our document when we release it, but you can have either smart circuit splitters or whole home circuit monitoring, which is a little more involved. Like a few of these right 4 here, or these left 4 here, they plug in straight to your wall, and they're pretty easy. They're easy to use. You just plug in and go. And some of them have either 2 appliances or 2 EVs, or 1 EV and a dryer. They come with different like plugs on the outside. Simple switch here, for example, is hardwired, but the NeoCharge, the Dryer Buddy, and the Split Volt, these have the plugs built into them. And then, so the DCC and the smart current sensor, these 2 here are a little different. These are more EV focused. They will actually monitor a whole home's power usage and then send the rest of the power available to the EV to charge it, which is pretty interesting. And both of these, I think, are more, well, the DCC is more multifamily focused, And then the EV Duty describes their product as both for residential and multifamily setup. And one more thing to note, the simple switch here has a 240 volt, but also a 120 volt version as well. And I don't think any of the other versions have 120. And yeah, another thing to note, because on these devices, they either switch between one product and the other. So in the example of an EV and a dryer, you'll be charging your EV, turn on your dryer, it will pause the EV charging until your drying is done. And then after that, send the power back to the EV. But some of these have continuous power to two devices. The NeoCharge, for example, has one for two EVs. So you can charge your EVs, but at a lesser rate at the same time. And that's one of the main features that distinguishes between these. Yeah, I think that covers it. So these are two, I'm going to show two examples of kind of like a whole home panel. And this is kind of like the essence of our watt diet 100 amp home. So this is showing a typical home on a 100 amp panel. Most of the loads here, like lighting and plug loads, those are kind of like a baseline amount from the NEC, National Electrical Code. Things like your garbage disposal have to be hardwired. And the plug-in devices are also a like baseline amount allowed by the NEC. So these are kind of like a typical setup that you would see in most homes. And where, you know, the examples will change that I'm going to show is in the HVAC and the EV charging, heat pump water heaters, the range, and the dryers, these bottom ones. So the two examples I'm going to show, they're located in San Francisco area, and they have like typical insulation. In this example, this is roughly a 3-ton system, and it is ducted, so it has a air handler. And this also includes a range, so that's a full-sized range, 4 burners, and with an oven. And then one thing to note here, the heat pump water heater, you can actually get a like medium power ream heat pump water heater that is 15 amps. So that would be on a 20 amp circuit. So it does use a little less power than a typical heat pump water heater. And then also this dryer here is a heat pump dryer that has a little less amps than, or quite a few less amps than a typical resistance dryer. And this, calculating all this up, you're under 100 amps, and you can fit all of your electric loads in a 100 amp panel. And then going to our next example, I know it's a lot on one slide, but if you have questions, we can discuss more. So this is the example 2, and this one we wanted to showcase that, you know, what if you use these power sharing devices that I showed? How many watts could you save on your panel? And then also comparing the last example to this one, we switched from a ducted heat pump to a ductless heat pump. So you no longer have the air handler loads on the panel. And
note that
yes.
a 3,000 square foot house.
Yes. So with the power sharing devices, we kind of upped the square footage. And the main thing about upping the square footage is the size of the heat pump. So the previous one was 3 tons, and this one is 4 tons. And that kind of just goes into the calculation of how much power the heat pump is using. So larger square footage, upping the heat pump power. So, and the power sharing devices that are shown here are between the dryer and the heat pump water heater. And since you are sharing these two loads, it is a 30 amp circuit, so it's a higher power circuit instead of the heat pump dryer that I showed before. And this is a full power heat pump water heater, so it is 30 amps as opposed to 15 amps in the previous example. And also, we're showing the range and EV charger as another power sharing opportunity. And then everything else stayed the same between the two examples. And yeah, one thing I did not know about the previous example is the EV charging rate. So basically we calculated that on like the space left over on the panel, or let's see here. Well, not the space left over on the panel, sorry, backtracking here. Calculated this based on the circuit that was available for this. So since we're power sharing, we're going to use more power for the EV because we're sharing that circuit with the range. So it's a roughly 38 miles per hour using this 40 amp circuit and like a typical EV. And then I'll just flip back to the previous one here. The EV charger is on a smaller circuit here, and it's roughly 19 miles per hour of charging. And that's just an interesting way to frame the different circuit sizes. How much charging are you going to get with your EV? So yeah, I think that about covers it. Do we have any questions on these? Or Sean, if you want to add anything to that?
Well, Dietmar was just writing in asking if we were using the derating allowances. And yes, that is what I just typed to him, but that was an important question. He was asking, is that, are we using the full allowances within the NEC code? For sure.
Okay.
Yeah, I think you can continue on.
Sure. And so also in our guide, we have lots of case studies from all over the country: Los Angeles, Massachusetts, Ohio, Arcata, and California. So lots of good content there. And then this image to the right here, I just wanted to show is one of the case studies that are actually using the power sharing device. This is the NeoCharge here, and they are, I believe, sharing their stove with their water heater.
Yeah.
Yes, confirmed from Sean. And this is like plug in, ready to go. And then they also have another power sharing device between their two EVs. And I believe it's also the NeoCharge that can do continuous charging to two EVs at a time. So that's kind of cool. And then I'm going to just show two case studies more in detail that we have the cost information for. So this is one in Cleveland, Ohio by Energy Smart Ohio. They were the energy consultants here. So things to note, they are using a cold climate heat pump. So slightly higher efficiency with more modulating capabilities. And they did do a shell upgrade here. The total cost is roughly $31,000 to retrofit this home. Yeah, I think that's all I want to say there. And our next one is kind of an interesting one. This is a do-it-yourself example in San Francisco. And they have the cost data here and also their labor hours they use to install these different items. And I just wanted to highlight here their HVAC strategy. It was all 120 volt, so easily plug in and ready to go. I think with the mini split, it was just some additional work on making sure they mounted it correctly and drilled a hole through a wall and that kind of thing to make sure it all works properly. So yeah, that was an interesting solution there. Continuing on. And then this is kind of just showing some highlights of our product guides. I'm sure some of you have seen it before. We updated a lot of the content here with a few new sections. And electric cooking, heat pump water heaters, electric dryers, HVAC, EVs. We have the energy management system. We added in solar PV panels and some backup batteries. And then we also have some fun stuff like outdoor recreation, all electric lifestyle, heat pump, pool and spa heating, electric saunas, fireplaces, outdoor heating, landscaping, and barbecue. So be sure to check those out. And just to quickly go through some of the highlights of the changes, I'm checking the time here. Yeah, we got about 10 minutes. Yeah, so I talked about this before in one of our case study examples. There are solutions to 120-volt heating and cooling. And the main reason I'm highlighting this is because the higher power circuits are often limited in homes. And, you know, if you're going to run a new wiring circuit, you might have to hire an electrician if you're not qualified yourself to do that kind of work. So yeah, so shown here are the package terminal heat pumps. The Innova product is pretty cool. That goes on any exterior wall, but it goes through the wall, versus these other products here go through the window. And then there's several ductless mini splits that are 120 volt, and they're all one zone. So applicable for a smaller home. And then I showed these in one of my previous examples. A lot of passive house and smaller apartments use ERVs and mini splits combined. But these products here are both ERV, HRVs, and heat pumps. They have heat pumps built into them. So applicable to, like I said, smaller apartments that need a smaller heating load, and they're pretty cool. Also providing, you know, fresh air that's filtered and all that good stuff. And then these products are pretty cool. So this is like retrofits for renters. This product here, the higher it is, you know, you just plug this into your wall. You put two, you know, they either come with one pipe or two pipes, or two ducts, I guess, not a pipe. And you put those two like through a window, for example, and you can get heating and cooling in a portable fashion. And this one, the higher, goes to below, well, around 10 degrees, I believe. So the higher, for example, will go to lower temperatures than some of these other ones, but pretty cool products if you're looking for a quick solution if you're a renter. And coming soon, I'm sure a lot of you have heard this before, are retrofit ready heat pump water heaters. Both GE and Rheem have announced that they're going to do this. And like I said before, there are options. Rheem has an option for a like medium power heat pump water heater that's 15 amps instead of 30 amps, like the other leading manufacturers. And some other things I wanted to highlight. I know we all have the power safety shutoffs on our mind. And I wanted to like have a section on low cost resilience. Like, what do these batteries look like? They range from like, you know, 200-ish up to $5,000. You can buy a battery off the shelf and power some of the loads in your home. And some of these smaller ones would be more for, you know, charging your phone, charging a laptop. But these very large ones, you could connect a fridge, for example, and bigger loads pretty much, because they have a higher amperage output rating. And most of them connect to solar panels too, which is pretty cool. Another point on low cost resilience, there are light bulbs with batteries inside of them, which are pretty cool. So if your power goes out, you still have a few hours of lighting. Yeah, just wanted to note, yeah, 3 to 4 to 5 hours of lighting, which is pretty cool. Another thing to highlight, part of one of the strategies that we do talk about a lot is using your EV to power your home. And these are the companies that say they're going to release products soon that are able to do this. I'm not sure, you know, we wrote this a little while ago, but the ones that are, you know, very close to being released are Wallbox and the Asiaco. And this product's interesting because it's also a solar inverter, which is pretty cool, and EV charger, etc. And some fun stuff. There are vintage looking induction ranges, you know, ranging, they're like on the higher end, but pretty cool looking if you're going for that vintage retrofit style. And another thing I wanted to highlight, there are ways to do high efficiency cookware or high efficiency cooking by using crock pots and pressure cookers. This is just kind of a fun analysis that we did that you can read more about in our document. And then also a new addition is looking at kitchen hoods that will meet the new proposed sound and CFM requirements in California. We saw at one of our projects that, the kitchen hoods were so noisy, people don't want to turn them on. Even in my own house, my mom never wants to turn on her kitchen hood because it's so loud. So these are low zone and high CFM kitchen hoods. Again, more fun stuff, electric snow blowers and snowmobiles for our cold climate friends. And a little bit of EV recreation inspiration. A few of these trucks, electric vehicle trucks, have kind of like their marketing focus at the outdoor lifestyle, which is pretty cool. Rivian, for example, has a whole setup. You just pull it out and it has a cooking setup and they come with pans, I believe. It's pretty cool. And then Nissan has a van, all electric van, ready for your next adventure. And again, dryers. Another thing we like to highlight, the combo washer dryers and heat pump dryers do use a lot less energy than your typical resistance dryer. And that's it.
Woo! Well done. Showing how to get it done. Thank you, Emily. Philip wanted to know, are the Nissan EV vans for sale in the US? Question mark, question mark.
I'm not sure. I'm not sure.
We'll find out.
Yeah.
That sweet Volkswagen one too.
I believe the Volkswagen is just like a demo so far.
Yeah, special edition, not widely available. Let's see, we do have electric barbecues in there. That was a question.
Yes.
Is there, I think that Dan Johnson made a very good point that we should add e-bikes and e-scooters.
Yeah.
Transportation, that's, I understand. Good feedback. Thank you, Dan. I think Gary asked, was there any concern in turning off power to compressors like a heat pump, water heater, or clothes dryers without a controlled shutdown? And the answer is, at least with the water heaters, no. We've consulted with the water heater companies, and they're fine with having their product shut down much more often than the relatively rare time that would happen on a power sharing circuit. They get used that way, just turned on and off by utilities around the country that have remote controls on them for grid management. So it's just fine. Shut them on, shut them off. I don't know so much about heat pump water heaters. Sorry, about dryers. But it's just for lack of experience.
Mm-hmm.
I can say my condensing washer dryer, it turns on and has all the brains built into it. There's no drama. It just like turns on, plug it in, boom. Oh, I push play, Very simple. Well, we're at time and I want to go get some lunch. So we've got 30-minute break here. I'll put up a slide. If there's any other questions, stick them into the chat. Well done, Emily. Well done. Robert Whitehair, we do not have ceiling fans, although we should, right? DC ceiling fans. We've been focusing on things that are very closely tied to electrification as opposed to more generally on energy efficiency. And as an air conditioning reduction, it's already an electric load. I mean, it's a good thing. It lowers the perceived temperature from 80 degrees to 60 degrees. That's how fans can take like a whole 20-degree temperature drop in the experience. But no, I don't think we're going to put it in for a little while. And Jean Wu, are there surge issues with heat pump water heaters or heat pumps? I don't know. I haven't heard of surge issues.
I think he's referring to when they do start up, there is a surge of power.
Mm-hmm.
But I'm not I'm not clear how the NEC accounts for that. We followed, just their rated, we use their rated power in those calculations.
Yeah. We think we're following the code. We've had like a whole team of us working on it, including Tom, who's very active in chat. Thank you, Tom.